Welcome to lesson 2.5. We're going to talk about logarithms, and this is going to be part 2 of logarithms. So we are going to solve exponential equations with logarithms. You're going to isolate the exponential. You're going to take the log of both sides of the equation. You're going to use the exponent property of logs to rewrite the equation and divide as needed in order to solve. So first example here, we would be given this here. 638 equals 500, parentheses, 1 plus 0.05 to the power of n. First off, you want to get the stuff in parentheses with the exponent by itself first. So we want to focus on this here. We want that by itself. In order to do so, we have to get rid of the 500. So that's why we divide by 500 on both sides. Cancels out. 638 divided by 500 gives you 1.276. That equals 1.05 to the power of n. We got 1.05 because we did 1 plus 0.05. At this point, we have nothing more we can combine or simplify, and our variable is stuck as an exponent. So in order to bring that down, we're going to take the log of both sides like we did in the last video. If you recall, when we had a variable as an exponent, that comes down in front of the log. So that would give us this step here. Log of 1.276 equals n times log 1.05. We are solving for n, so like you've done in all of algebra before, you're going to divide in order to get n by itself. That has you doing log 1.276, make sure to close the parenthesis, divided by log 1.05. You throw that in your calculator, and you should get n equals 4.9955. All right, we have another example here. Let P of t equal 26,000, parentheses, 1.02 to the power of t. Let that be the population of a town after t amount of years after the year 2000. They want you to estimate the year when the population will reach 29,866. So some information we can pull from this. N equals 0 is our year 0. We're doing after the year 2000. Our initial population, remember this number in front is the initial population, which is at 26,000. So in order to write this exponential equation, we're going to take the goal of 29,866, because that's how much of a population we're wanting, equals our original population, which was at 26,000, parentheses, 1.02 to the power of t. And again, that's coming from this equation here, where 29,866 is just the end goal that we're putting in place of P of t. Now, here we're wanting to work towards getting the part with the variable by itself, so we got to get rid of the 26,000 by dividing. 29,866 divided by 26,000 leaves you with 1.1487. That is equal to 1.02 to the power of t. Again, what we've been doing at this step, we can't do any more to this, so we're going to take the log of both sides. That gives us log of 1.1487 equals log 1.02 to the power of t. Again, remember, when you have an exponent, that comes down in front of your log, so that gets us here, where we have log 1.1487 equals t log 1.02. We're wanting to solve for t, so you're going to divide by log 1.02 on each side. Log 1.1487 divided by log 1.02 is going to come out to 7 years. It wants to know estimate the year though, so 7 is not your final answer. This is t years after 2000, so this is 7 years after 2000, meaning that would be the year 2007. All right, one last example here for this. India had a population in 2008 of about 1.14 billion people. The population is growing by about 1.34% each year. If this trend continues, when will India's population reach 1.2 billion? So, some information that we're able to pull from this. 2008 is our first year, so that's n equals 0, our original year. Our rate is 1.34%. That came from here. Remember to divide this by 100 to get your little r, which is the rate of the decimal. So that'd be 0.0134. P of 0 is your original population. Now, for the sake of making it simpler, we're going to drop the word billion off of these since they're both billion, and we're going to just use 1.14. P of n is our end goal, which is 1.2. We're trying to figure out when does n give us 1.2. So if you recall to write an exponential equation, we're going to do our end goal, 1.2, equals our original of 1.14, parentheses 1 plus our little r, which is 0.134, to the power of n. We are wanting to take this here and we're wanting to get the variable by itself like we've been doing in the previous examples. So we're going to divide both sides by this 1.14. 1.2 divided by 1.14 is 1.0526. That is going to equal 1.1034 to the power of n, because we just added these two together to get this. As we've been doing, we want to bring this n down, so we're going to take the log of both sides and drop the n down in front. So this gives us log 1.0526 equals n log 1.0134. We want to solve for n, so you divide by log 1.1034 on both sides. You throw this monstrosity into your calculator. You're going to get n is 3.85. We don't really have 3.85 years, so we're going to go ahead and run it to the nearest whole number, which is in 4 years. Again, it wants to know when. So it's not saying in 4 years, it's what year is that. Well, 2008 plus 4 would say that it happens in 2012.